Hi, everybody. Mr. Rubo here. And today we are going to start talking about topics 3.4 and 3.5. We're kind of grouping those together because they are very similar. So they deal with sine and cosine graphs, okay, and sinusoidal functions in total, okay. So in this section, we will develop and understand how to represent sine and cosine functions graphically, where theta is our input value, represented on the horizontal axis, and the sine or cosine value represents our output values, or f of theta, represented on the vertical axis, okay. Oh, tiny. I believe there should be a parenthesis there. Yeah, I think so. I think that should be a parenthesis, but whatever. All right, so the sine graph we're going to write as f of theta. Oh, theta equals, oh man, my pen does not want to work. Sine of theta. Okay, so what we're going to do here is we're going to find these values and then plot them. Okay, and the nice thing is, because it's periodic, you'll see we only need to know these values to do this. Okay, so and all of these values we're going to start, like, we've dealt with so much that I'm just going to kind of go through them. You could draw the triangle if you need to, but I'm going to kind of give you a lot of these answers. So pi 6, sine of pi 6 is 1/2. Sine of pi thirds is root 3 over 2. Sine of pi halves is 1. And then we're going to see a lot of the repeating things. So now we're in quadrant 2. 2 pi thirds, well, it's still going to be root 3 over 2. And then 5 pi over 6, it's going to be 1/2. And then being, back at pi, it's going to be 0. And then we're going to be going to the third quadrant with these two. So this would make them negative. So it's negative 1/2 and then negative root 3 over 2. And then at 3 pi over 2, we're exact opposite of pi halves, so it's negative 1. And then negative root 3 over 2, negative 1/2. And then back to 0. And again, maybe you needed to draw the triangles, but I kind of gave you these. So now we're going to plot these points. Now you may be like, oh, well, I don't know what root 3 over 2 is. You could estimate it, but graphic, or if you were to put it in the calculator, root 3 over 2 is roughly equal to 0.866. Okay, so we're going to start plotting these points. So at pi 6, we're at 1/2. Crazy, it's like it's scaled that way. Pi thirds, we're somewhere in between 1 and 1/2, so I'm going to estimate it there. At pi halves, we're up at 1. At 2 pi thirds, we're at the same value as we were at pi thirds. 5 pi 6, we're at 1/2. Pi, we're at 0. 7 pi over 6, we're at negative 1/2. 5 pi thirds, I'm sorry, 4 pi thirds, negative 0.866, if you will. Then we're at negative 1. Coming back. Here we go. Okay. And so this graph, if I connect it, and I will also put in, well, at sine of 0 is also 0. So I'm going to throw that one in. So I'm going to go ahead and connect this. And guess what? We just created a sine wave. And this is how these graphs will look. It's just this pattern repeated over and over and over again. So a few things. The midline is the middle of the graph. And so here our midline is at y equals 0. Okay. Then a couple things as far as the equation goes. There is also this height here. We are going to call this the amplitude, which we represent by the absolute value of our a. It's this distance. So it's 1 in this case. And then our last big piece of information that we're going to look at from the graph is this length here, because that's the whole thing it takes to repeat, which we've talked about before. We call that our period. So the normal period of a sine function is 2 pi. Okay, and then there's one more thing we're going to look at. So I'm going to kind of fill this in as we kind of do. So 2 pi is our normal period. The midline is in between, so it's y equals 0. Our amplitude in this case is 1. which we're going to say a equals 1. And then we're going to talk about frequency. So frequency, if you're taking physics or have taken physics, you probably know this. But mathematically, the frequency is the reciprocal of the period. So in this case, it is 1 over 2 pi and then the last thing here, the graph of f of theta equals sine of theta, oscillates between concave down and concave up. Technically, you could write it either way, but graphically, the way we graphed it, the concave down part started first and then went concave up. Okay. So yeah, there you go. There's the important things of sine. Well, guess what? Cosine, very similar. So we're going to go ahead and do that as well in this video. So we're going to do f of theta equals cosine of theta. Okay. And we're going to find all these. And guess what? They're all the same values. They're just switched. So at pi 6, it's root 3 over 2. Pi thirds is 1/2. Here it's 0 at pi halves. And now we get into this quadrant 2, which is negative. So negative 1/2, negative root 3 over 2. Pen stopped working. There we go. Negative root 3 over 2. And then we're at negative 1 for pi. And then we're in quadrant 3. So again, still negative. And then we're at 0 again. And then we're going to be in quadrant 4, which then means the x values, the cosine values are positive. And we get that. And then at 2 pi, we're at 1. All right. So now we're going to plot these points. Okay. Oh, and I'm sorry. This was g of theta, because that's what they want here. So at pi 6, we were up here. Then at pi thirds, we're at 1/2. Pi halves, we're at 0. Negative 1/2. There we go. Pi, we were at negative 1. And then we work our way back. And yeah, this is our pattern. And I'll give you the cosine of 0 is also 1, just so we can kind of have that graph there. So this guy is what cosine, this is what cosine looks like. Oh no. It's very hard when you're right-handed and the graph, when your hand covers what you want to draw. It's easier to draw this left-handed if I were to be honest. So yeah, you have the cosine graph here. Pretend I actually connected this very well. If you look at a cosine graph and a sine graph, they look identical. The key, though, to know the difference between them, at least without shifts, is sine starts. So going back a little bit, sine starts, I put quotes around that, at the midline. Okay, I say starts, the y-intercept will be the midline. Okay, as far as the y-intercept in a cosine, it's going to either be at a maximum or a minimum value. Basically, if you have a reflection, that's how you would get it at a minimum value. Okay, so yeah, so that's why we care about that. So guess what? The properties are pretty much, and not pretty much, they are the exact same. So it's 2 pi, frequency is the reciprocal of the period. Midline is normally at y equals 0 unless there's a shift. Amplitude is that a equals 1, and then it also oscillates between concave down and concave up. Okay. All right. Thanks for watching. That's the basics on sine and cosine graphs. So yeah, thanks for watching. Have a good day.